Hello everyone, this is Sir Kurbah speaking. I am glad to guide you using this platform of teachings as the normal classes are being disrupted by the pandemic. And at the same time, this will help you to get engaged yourself in your studies. Please listen carefully with concentration, and I hope that you will be able to understand it. Now, before we move ahead, I want you to after the end of this video, you please go to the description box of my channel, and from there you will get the option to download the exercise in PDF formats so that you can refer or you can note down in your exercise book for your ready reference. Okay. Now, before we start with this chapter, let us first know something about a quadratic equation. What is a quadratic equation? A polynomial fx, where fx equals 0, that polynomial will be called as a quadratic equation. A quadratic equation fx is equal 2x square. Here I have given you as example fx equal 2x square minus 3x plus 2. This is a polynomial, and if fx is 0, that means 2x square minus 3x plus 2 is 0. This whole equation will be called as a quadratic equation. Okay, now let's come to the standard form of a quadratic equation. What is a standard form of quadratic equation? When the terms of a quadratic equation are written in descending order of the degrees, that is of their variables, then that equation is in the standard form. Now, what is their degree? What of degree? That means you have to look for the variables in each of the term of the equation. You look for the variable and what is their degree, and if you arrange them in a proper order, that means in descending order of their degree, that arrangement will be called as the standard form of a quadratic equation. The standard form of quadratic equation is represented by this equation: ax square plus bx plus c is 0. What is a? A is the quotient of x square. What is b? B is the quotient of x. And what is c? C is the constant term. See, quotient of x square, b is quotient of x, and c is the constant term, that is just a numerical value. Any numerical value will be called as a constant. Okay, now here I've given you the table where you will be acquainted, you try to be acquainted yourself with the quotient of x square, quotient of x, and the constant term. In the first example, 3x square minus 4x plus 5 is 0. What is the quotient of x square here? Quotient of x square is 3. Quotient of x is minus 4. You have to look for the sign also, because in the standard form all are with plus, and if any of the term is with minus, then that quotient will be with minus sign. Quotient of x here is minus 4 and constant is 5. The next example, 2x square plus 5x minus 3 is 0. What is the quotient of x square? It is 2. Quotient of x 5 and constant it is minus 3. The next, x square plus 2x minus 1. Same thing here also. Here x square, which numerical value is there together with x square? There is no numerical value. You will always assume to be 1. 1 is the quotient of x square. Quotient of x is 2 and a constant is minus 1. In the next, we have 2x square minus 5 equals 0. Is this a quadratic equation? Yes, because the degree is 2. Always remember that the degree of the quadratic equation should always be 2. Now this is a quadratic equation, though it have only 2 terms. Actually it should be 3, but here have only 2 terms. Even then, this is a quadratic equation. The quotient of 2 of x squared being 2, quotient of x, there is no x term here, that means it will be 0, and the constant term, it is minus 5. In the last example, you look carefully at the given polynomial. The term are putting not in order. That means not in the standard form. In the first term is x squared, second term only 3, and last term 2x. That means the order of the variable according to the power is not in order. Here the power of x here is 2. Here in second term there is no x. In the third term power of x is 1. Therefore, in choosing the coefficient, you have to look for the numerical value that is together with x squared or x. Here together with x squared, the numerical value, the number which is there with x squared, it is 4. That means the coefficient of x squared is 4. Coefficient of x here it is 2, and constant it will be minus 3. Okay, I think you are clear with the coefficient of x squared and x and the constant term from this given example. Now we go to the roots of a quadratic equation. What is how we can find out the roots, or what are the nature of the roots, how we can determine the nature of these roots? We'll discuss this, and from here we'll know what will be the nature. In any quadratic equation, any quadratic equation should always have 2 roots because of degree 2. Because of degree 2, it should always have 2 roots, and the nature of the roots depend upon the discriminant. The discriminant depend upon the discriminant, which is also given by b square minus 4ac. Discriminant is b square minus 4ac. Now the nature of the roots will depend upon this b square minus 4ac or the discriminant. If discriminant is greater than 0, then what will happen? The equation will have real and distinct root. That means they'll have 2 roots which are real and distinct. If d is equal 0, the roots are real, and then both of them are equal. And the third, if d is less than 0, the equation will have no real roots. That means you cannot find out the roots of the equation because they are imaginary. No real roots mean they are imaginary roots. Okay, for that to solve for these imaginary roots, you will not be doing here in class 10. That will be done in when you reach class 12 or above. But here in class 10 we'll discuss discuss only for these real roots and the equal roots. Okay, now solution for to a quadratic equation. How will solve a quadratic equation? As we know that the quadratic equation has 2 roots or 2 solutions, and these roots can be found out by any of the following methods. What are those methods? Number first, solving by factorization or by splitting the middle term. I think you have come across factorizing by splitting the middle term. And then second one is by completion of square, which I'm going to teach you in the next few classes. And the third one is by using a quadratic formula. These are the 3 methods by which we can find out the roots of a quadratic equation. What is the formula? This formula you have to note it down and remember it. The roots will be given by minus b plus minus root over d by 2a. What is d? D is b square minus 4ac. What is b? B is the coefficient of x. What is a? A is the quotient of x square. Okay, we will be using this formula to solve or to find out the roots of quadratic equation in the next few classes. Okay, just remember this is the very useful formula that we'll have to come across. Okay, now let us recall what is what we have learned up till now. A quadratic equation should always have the highest degree as 2. Why? Because if it's degree of 1, that will be called as a linear equation. If degree is 3, it is a cubic equation. If more than 3 is 4, is biquadratic equation. That's mean if and only if the degree is 2, then that will be called as a quadratic equation. Okay, if it's less than 2 or more than 2, that will be a different type of equation. If 1 is linear, if 3 is cubic, if 4 is biquadratic, and so on. But will we concern ourselves in this chapter with the degree of 2, that is a quadratic equation. Okay, the next recall is that regarding transposition. That means if you take any term from the left to the right or the right to the left of the equal sign, their sign will change. If it's plus, it will change to minus. If it's minus, will change to plus. I think this you have come across right from very lower classes also, but this basic rule will be remaining the same. Even if you are going to higher classes also, this thing will remain the same. The basic rule of mathematics should be the same. Okay, like here I've given you example 3x square minus 2x minus 1. Here 1 is on the right side. If you bring this 1 to the left side of the equation, this is plus, it will change to minus sign. Okay, in the next example 2 is equal to 3x square minus 5x. Now what we have to do here, if you bring this 3x square from the right to the left, it will change to minus 3x square. It will not looking nice if the first term being minus, and if possible will make it to positive sign. Okay, what we'll have to do then, you will see for the left hand side. Left hand side is 2. Now what will happen if I take this 2 to the right side? If I take to the right side, what will happen? I will get 3x square minus 5x, and then this 2 when you bring to this side will change to minus 2. Okay, will change minus 2, and what's remaining on the left side? There is 0. That means you can write the whole equation, simply interchange the position. You'll write 3x square minus 5x minus 2 equal 0. Okay, and this is also very important that you will be most of the time you will be using this, because if you take this 3x square to the left, it will change to minus, and then this 5 will change again, minus will change to plus. It will be not very nice to look at it, but if you do in this way, if you take this 2 on the left to the right, you will just change the sign of 2 to minus 2, and then the whole thing, the whole equation, you just interchange the places. That will be looking good. Okay, now coming next to the similar term. What is a similar term? Similar term, they are the term which are similar in their composition. Now 3, minus 2, 1, 5, 6, 7, 8, all these are numbers only. They are constant, they are number. Therefore this term, they are grouped as a similar term. Now those terms which contain x, maybe minus x, plus x, 3x, 5x, 4x, any term which contain x, all those terms will be similar. And then again with those terms will have x squared, either x squared or y squared or z squared. If they have if all of them, if like here 2x squared, 3x squared, minus 2x squared, x squared, 5x squared, all this will be called as the similar term because they have the same x squared in common. Okay, now if you look on the last example I've given here, root 3 and root 2x, are these two similar? Yes or no? It's no. Why? Because here root 3 is a constant. It's just a constant. But here root 2x is a variable. X is a variable. That means this root 2 is together with a variable. A variable and constant, they are completely different. That's why they are not similar term. Okay. Okay, for this portion, we'll stop it till here, and we'll continue it in the next part, that is in the part 2. Are clear of you? I hope that within next few days I will be uploading the part 2 of this chapter 4, and in the meantime, you please, all of you, stay safe, and bye to all of you. Thank you.